Lagrangian and Hamiltonian formulation. We have Lagrangian and Hamiltonian formulations mother will have certain conditions that we have already looked at the points. What are the limitations of this Newtonian mechanics? Then we'll have a point that is the constraints. Okay, the constraints are nothing but the restrictions on the motion. Okay, ekadi motion will have a consideration of simple pendulum. So in terms of that, we'll just hang it in to the rigid support. Then we'll just move in a xy plane. So that is one constraint. Its length is fixed. And the second one is that it cannot move in a z axis. Okay, so you just have a movement like this. Okay, so you have this conditions. So this is theta, this is L, and you just say the simple pendulum is fixed to the rigid support. So the first constraint is length is fixed, and the second constraint is it only moves in an xy plane. So for that, this z value is equal to 0. That we have already seen. So there are two types: holonomic constraints and non-holonomic constraints. Holonomic, that is in terms of equations, and non-holonomic, that is in terms of inequalities, or you can just say in terms of equalities. Okay, so holonomics are an example of the rigid body. So for that, you can just have a fixed coordinates, and for a non-holonomic, you'll have a particle that is moving, or you can say that is moving in or outside the sphere. Okay, so we'll have that conditions. Also, we have classified this in terms of rheonomous and scleronomous constraints. So, rheonomous constraints are the constraints in which the time is the explicit variable. The equations in which time is involved, this is called as an rheonomous constraints. And the constraints in which the time is not an explicit variable, which is called as scleronomous constraints. So, हे दोन प्रकार आपण याच्यामध्ये पाहिलेले होते. Now we'll have the next thing that is called as DOF. Okay, so this DOF is nothing but degrees of freedom. So now look at this point. So we have to consider a motion of a free particle. So you can describe its motion in a way that is called as a Cartesian coordinate system. Or you can say in terms of a spherical polar coordinate system, that is nothing but r theta phi. So you can express this motion of the free particle as a coordinates x, y, z, or a coordinate that is called as a r, theta, and phi. Now, we just have a point. If you can have these three independent coordinates, either x, y, z, or r, theta, phi, these three coordinates can be described, or that can just say the free particles like this. So these free particles, that is, that can move freely along this three axis. Let us say this x, y, z. So this particle that can move in a three-dimensional space. So I can just have a look. Just look at this condition. If I have a sphere, not a sphere, a cube. Okay, and now just look at this point. So I have three axes. This is x, this is y, and this is z. And now we just consider the free particle. So what do we say? This particle can go along x-axis, that can go along y-axis, and that can go along z-axis. So the motion of the particle, free particle, that can be in all these three directions, and hence this is called as a free particle. Is having a 3 degrees of freedom. सगळ्यांना लक्षात येत आहे? ये जो free particle है, that can move along all these three directions. Okay, so that can be, you can just say the free particle that move along any one axis independently. Okay, with change in one coordinate only. So you can have that. It is considered to have 3 degrees of freedom. Free particle A gap, and so for that one free particle, it will have a 3 degrees of freedom. Now, let us say we have an n number of particles. Okay, this n number of particles are having 3n degrees of freedom. एका पार्टिकल साठी किती आहे? एका पार्टिकल साठी 3 डिग्रीज आहे. सो n पार्टिकल साठी is 3n तुमचे डिग्रीज ऑफ फ्रीडम असतील. If we just say these particles are free from constraints. काय कन्स्ट्रेंट केलं आहे? जर हे जे पार्टिकल्स आहेत याच्यावरती कुठल्याच प्रकारचा कन्स्ट्रेंट नसेल, कन्स्ट्रेंट इन द सेन्स रेस्ट्रिक्शन नसेल, तर त्यासाठी किती डिग्रीज ऑफ फ्रीडम असतील? So it is considered to have a 3n number of 3n degrees of freedom. Now, we'll just say, आता आपण पाहतोय की particles जे आहेत, they are generally having some degrees of freedom, and that's why not the degrees of freedom, they are having some restrictions. Okay, they are having some constraints, आणि ह्या constraints मुळे आपल्याला ही जी गोष्ट आहे तशीच कन्सिडर करता येणार नाही. और जस्ट देयर आर नो 3n इंडिपेंडेंट कोऑर्डिनेट्स. ठीक आहे, हे जे काही 3n कोऑर्डिनेट्स आहेत ते आपल्याला आहे तसेच घेता येणार नाहीये. लेट अस से वी विल हैव सम holonomic constraints. Okay, and that holonomic constraints are, let us say, having some key equations. सगळ्यांनी लक्षात येत आहे? हे जे काही आपण 3n डिग्रीज ऑफ फ्रीडम म्हणतोय, हे कधी कन्सिडर करतोय की त्यावेळेस कुठल्याच प्रकारचे कन्स्ट्रेंट नाहीये. नाउ जस्ट से if there are some constraints, let us say k equations of constraint, and so we can have just say the number of independent coordinates are not 3n, but the number of independent coordinates are nothing but 3n minus 3. महत्वाचं आहे, लक्षामध्ये घ्या. काय सांगतोय? k इक्वेशन ऑफ कन्स्ट्रेंट्स आहे, आणि जर k इक्वेशन ऑफ कन्स्ट्रेंट्स असतील तर त्याच्यामध्ये हे जे काही 3n आपण डिग्रीज ऑफ फ्रीडम म्हणतोय ते तशा राहणार नाहीयेत. ते इंडिपेंडेंट कोऑर्डिनेट राहणार नाहीत. मग किती राहतील? तर ते राहतील एवढे 3n k. जेवढे काही इक्वेशन ऑफ कन्स्ट्रेंट्स आहेत ते त्याच्यातून वजा करायचे, सबट्रॅक्ट करायचे, आणि जे काही उत्तर येईल त्याला म्हणायचं इंडिपेंडेंट कोऑर्डिनेट, और यू कैन से these are nothing but the degrees of freedom. So you can have 2 points. If you do not have any degrees of any constraint, then we have degrees of freedom for n number of particles, that is 3n, and you can just say in otherwise you can consider some holonomic constraints, and that holonomic constraints contains, let us say, k equations. So the number of degrees of freedom are not 3n, but it becomes 3n minus k. So this is called as the degrees of freedom. So how can we define this? Okay, so you can define it like this. The number of ways in which, let us write it here, the number of ways in which violating any constraint which are imposed on the system. लक्षात येते का पहा. Now we are going to just look at this degrees of freedom. What is degrees of freedom? So it is the way. Okay. So how many ways? You can just there are number of ways in which the system, the mechanical system can move. Okay. So you have to consider the motion of that mechanical system. Okay. But that we have to consider without this is violating the constraints. आपण त्या सिस्टीम वरती किती कन्स्ट्रेंट्स अप्लाय करतोय किंवा त्याचे काही कन्स्ट्रेंट्स आहेत त्यांना व्हायोलेट न करता ओके ते आहे तसेच ठेवून आपल्याला काय करायची तुमची मेकॅनिकल सिस्टीम मूव्ह करायची. सो दिस इज द कंडिशन. म्हणजे काय त्याच्यावरती जेवढे इक्वेशन ऑफ कन्स्ट्रेंट्स असतील ते सगळे अप्लाय करून द्या. सगळ्या गोष्टी त्याच्यावरती अप्लाय करून द्या. जे काही गोष्टी तुमच्या शिल्लक राहतील दॅट मीन्स दिस 3 and minus k. So this is called as the degrees of freedom. So the number of ways in which a mechanical system can move without violating any constraints which are imposed on the system. जेवढे काही कन्स्ट्रेंट तुमच्या सिस्टीम वरती इंपोज केलेले आहेत ते आहेत तसेच ठेवून त्याला व्हायोलेट न करता तुमची सिस्टीम जी काही मूव्ह केली जाते मेकॅनिकल सिस्टीम जी काही मूव्ह होत आहे सो दॅट कन्सिडरेशन इज नोन ॲज द डिग्रीज ऑफ फ्रीडम. सो जस्ट रिमेंबर दिस पॉइंट. You have n particles and for that n particles let us say you can have this k equation of constraints and then you can just say that this consideration is known as the degrees of freedom. The next point is the generalized coordinates. So we have to look at the generalized coordinates. The generalized coordinates, these are nothing but the minimum number of coordinates. I'll just define it first. So this is the minimum number of coordinates which are used to describe which are required to describe the motion of the system which are required to describe the motion of the system at any time. Degrees of freedom पहिला पण the number of ways in which the mechanical system can move without violating the constraints which are imposed on that system. Now we have to look at the coordinates. So we have a question in your mind. What should be these coordinates? Okay. So we will have suppose this n number of particles and k equation of constraints. Then we just say we have 3n minus k degrees of freedom. Okay, हे तर आपण पाहिलं. मग आपल्याला काय करायचं आहे? आपल्याला आता करायचं आहे की जनरलाइज्ड कोऑर्डिनेट्स कशा पद्धतीने डिफाइन केले जातात, कशा पद्धतीने ते असू शकतात ते आता आपल्याला पाहायचं आहे. So just say what are the generalized coordinates? These are nothing but the minimum number of coordinates, okay, which are required. Minimum number of coordinates which are required to describe the motion of the system. एखाद्या सिस्टीमची मोशन जी आहे ती आपल्याला डिस्क्राइब करायची आणि त्यासाठी आपल्याला काही कोऑर्डिनेट्स लागतील. आपण पहिल्या चॅप्टर पासून प्रोजेक्टाइल मोशन असेल, रॉकेट मोशन असेल तर त्याचे मोशन्स आपण डिफाइन केलेले आहेत. सो इन टर्म्स ऑफ कार्टेशियन कोऑर्डिनेट असतील पहिल्या याच्यामध्ये सेंट्रल फोर्स मध्ये तुम्ही पाहिलं की आपण इक्वेशन ऑफ ऑर्बिट वगैरे पाहिलं दॅट इज इन टर्म्स ऑफ सम spherical polar coordinate system. So we'll have that different coordinate systems. Now we'll have in terms of Lagrangian and Hamiltonian. We'll have to use this generalized coordinate system. And that generalized coordinate system is nothing but the minimum number of coordinates that are required to describe the motion of the system at any time. So this is the condition. So at any time, we'll have to describe that system with minimum number of coordinates. So you can have that in terms of this point. So you just have this 3 n minus k degrees of freedom, and let us say the forces of constraints, okay, that are not always known because they may depends upon the motion itself. आता ते म्हणा की याच्यामध्ये जे काही 3 n minus k degrees of freedom आहे, so we'll have that equation of constraint, there may be some forces, okay. So just remember that these forces that may depends upon the motion of the system. कशा पद्धतीने तुमची मोशन आहे त्याच्यावरती जे काही फोर्सेस ऑफ कन्स्ट्रेंट्स आहे ते फोर्सेस ऑफ कन्स्ट्रेंट इथे डिपेंड्स असतील. And so you can just say we'll have to introduce some coordinates for this, and these coordinates that is given in terms of 3 n minus k degrees of freedom or independent coordinates that can be defined in terms of a coordinate that should be like this. You just say we have a generalized coordinates that can be defined in the way like this. Okay, so what is this? These are nothing but the generalized coordinates. You can just say q1, q2 up to q3n minus k. Why 3n minus k? Because we have this 3n minus k. These are called as the degrees of freedom. एवढा degrees of freedom आहे n particle साठी म्हणून आपण हे coordinates पुढे end करतोय. Just end it at 3n minus k. I'll just say this can also be written as in terms of q1, q2 up to qn. What is this small n? This small n is nothing but 3n minus k. Okay. दोन्ही पद्धतीने लिहिलं जातं. Either it can be written in terms of q1, q2 up to q3n minus k, or it can be written as up to qn, where this small n that is known as 3n minus k. So you can have that point. So we just said the independent variables, this q1, q2 up to qn, that can be expressed in terms of some old coordinates. आपले जे काही जुने coordinate systems आहेत x, y, z वगैरे असेल, ठीक आहे, और you can just say x1, y1, z1, x2, y2, z2 up to xn, yn, z याच्यामध्ये आपण हे एक्सप्रेस करू शकतो. So how can I write this? I can write it like this and just write it here. So have a point. That is, this x1 can be given as x1 of q1, q2 up to qn and t. Just remember that, we'll have a time that is always included in this generalized coordinates. ठीक है, ज्या वेळेस आपण हे जनरलाइज्ड कोऑर्डिनेट्स लिहिणार आहोत तर त्या वेळेस आपल्याला हा जो काही टाइम आहे हा त्याच्यामध्ये घ्यावा लागेल. सो x1 is like this. You just say y1 is equal to y1 of this q1, q2 up to qn t, or you can just say z1 is equal to z1 of q1, q2 up to qn of t. You can just say, you can express this new coordinates, that is nothing but the generalized coordinate, independent coordinate, in terms of your old coordinate system. So this is x1, y1, z1, then we can have x2, y2, z2. Like this, you can just write that for xn, yn, and zn. So what is xn? Xn nothing but xn of q1, q2 up to qn of t. Yn is nothing but yn of q1, q2 up to qn of t, and zn is zn of this q1, q2 up to qn of t. Okay, so you can just express all your coordinates up to n in terms of your coordinate that is called as generalized coordinate q1, q2, qn of t. Or in otherwise, we'll just say this can be also expressed as R1. Okay, so this is nothing but the vector xy, x1, y1, z1, x2, y2, z2. So I can just express it as R1 is equal to R1 of Q1, Q2 up to Qn of t. Similarly, you can define R2, that is R2 of Q1, Q2 up to Qn of t, or you can define like way Rn is equal to Rn of Q1, Q2, Qn of t. So you can also express all these coordinates, not small n, I will just write it capital N. Okay, small n is that. So I can express all our positions in terms of your generalized coordinates. So in general, this can be written as, that is Ri is equal to Ri of, okay. So these are nothing but the number of particles. I just write it as Ri is equal to Ri of Qjt. Ri is equal to Ri of Qjt. What is I? So just said the value of I is nothing but 1, 2, 3 up to capital N. What is J? The value of J is nothing but 1, 2, 3 up to small n. What is small n? The value of small n is nothing but 3n minus 3. So just remember that, we'll just generalize it and you can write that in this way. So Ri, okay, for your I particle, so Ri is nothing but Ri of Qjt. Remember that these values, value of I and J. I, that is nothing but 1, 2, 3. So this is 1, 2, 3 up to what? Up to capital N. And what is J? That is up to 1, 2, 3 up to small n. What is small n? So we have already defined that the value of small n is nothing but 3n minus k. So that is nothing but the generalized coordinates. सगळ्यांच्या लक्षामध्ये येतंय का पहा आपल्याला काय करायचे हे जे काही कोऑर्डिनेट्स आहेत x y z हे आपण यूज करणार आहोत but we just said that is not having particular dimensions or you can just have that different perspective. So we'll have to look at the generalized coordinate, that is the minimum number of ways in which we can describe the motion. ठीक है कुठल्या पद्धतीने आपण त्याची काही मोशन आहे त्या सिस्टमची ती मिनिमम नंबर ऑफ कोऑर्डिनेट्स मध्ये डिफाइन करू शकतो ते आपल्याला पाहायचं आहे that is called as generalized coordinate. And for that sense we'll just say we have this number of coordinates in terms of a generalized coordinate of independent variables. So we can have that q1, q2 up to q, 3n minus k. So this 3n minus k is because we can have that number of degrees of freedom. So you can just express old coordinates in terms of new coordinates, or you can just express in another way. म्हणजे आपण हे ri is equal to ri of qjt हे असं लिहिले आपण qj ची व्हॅल्यू किती लिहू शकतो. So this qj is nothing but qj of rit. सगळ्यांनी लक्षामध्ये येतं. So just express that in inverse way. So this is called as an inverse transformation. This is an inverse transformation. So we can use that in both the ways. Qj is equal to qj of rit, or you can just write that is this qj is equal to this qj of r1, r2 up to capital Rn. So you can have that points. Okay, so you just express it in various ways. So you just have that this qj. Remember that this qj is known as a generalized coordinate. So this is a generalized coordinate. So now the question is there in your mind, what should be the actual difference between a normal coordinate and a generalized coordinate? आपण जो काही नॉर्मल कोऑर्डिनेट लिहितोय, let's just say x y z, x and y and z and r1 r2 r3 याला कशाचे डायमेन्शन्स असतात? So it is having a dimensions of length. This x1, y1, z1, x2, y2, z2, r1, r2, rn, xn, yn, zn याला कशाचे डायमेन्शन्स आहे? It is having a dimensions of length. So remember, the first point for your generalized coordinate is that this qj. So the first point is this qj may not remember this, may not necessarily have a dimensions of length. म्हणजे आपण जे काही जनरलाइज्ड कोऑर्डिनेट्स qj लिहिला फॉर दॅट यू जस्ट से जसं इथं याला डायमेन्शन्स ऑफ लेंथ आहे तसं ह्या qj ला डायमेन्शन्स ऑफ लेंथ असतीलच असं नाही. ओके, मे नॉट नेसेसरीली, म्हणजे त्याला ते पर्टिक्युलरली डायमेन्शन्स ऑफ लेंथच आहे असं म्हणू शकत नाही. इट मे हॅव ए अँगल थीटा और यू कैन जस्ट से फाय or you can just say any other physical quantity. म्हणजे qj ला फक्त त्याचे डायमेन्शन्स ऑफ लेंथ असतील असं नाही. इट कॅन हॅव ए डायमेन्शन्स ऑफ एंगल और थीटा और फाय, और इट कॅन हॅव सम एनी अदर फिजिकल क्वांटिटी. दुसऱ्या काही फिजिकल क्वांटिटी जेवढ्या काय असतील तुम्हाला माहिती आहे तेवढ्या सगळ्या फिजिकल क्वांटिटीज आपण ह्या जनरलाइज्ड कोऑर्डिनेट्स मध्ये लिहू शकतो. सो दिस इज कॉल्ड एज जनरलाइज्ड. सो दिस इज जनरल. आपण जर xyz लिहिलं तर हे फक्त कशासाठी यूज केलं जातं? लेंथ साठी. बट दिस इज नॉट ऍक्च्युअली फॉर लेंथ ओनली, इट कॅन बी फॉर एंगल्स आल्सो. सो यू कॅन हॅव दॅट पॉइंट. सो इट जस्ट सेड द फर्स्ट पॉइंट इज qj may not necessarily have a dimensions of length, but it can be an angle theta or phi, or it is some different physical quantity. So you can have a second point, this qj. So it can be written in terms of this dq by dt. Okay, so this is given as in terms of velocity. Now I'll just say this is nothing but q dot. हे लक्षात ठेवा, आपल्याला यूज करायचं आहे. So this q dot is nothing but dq by dt. What is qj? Qj is generalized coordinate. What is q dot? This is called as dq by dt. It is called as a generalized velocity. सगळ्यांनी लक्षात येते का? q dot is dq by dt. Okay, qj or q is known as generalized coordinate, and so this q dot is called as generalized velocity. One more point, as q dot may not necessarily have a dimensions of length. Okay, so this q dot or dq by dt is not having a dimensions of velocity. जसं याला डायमेन्शन्स नाहीयेत लेंथचे, तसेच या q डॉटला किंवा जनरलाइज्ड वेलॉसिटीला डायमेन्शन्स कसे नाहीयेत, कशाचे नाहीयेत? इट मे नॉट हॅव or it cannot have a dimensions of velocity. That is your second point. What is the third thing? The third thing is that we cannot divide it in terms of groups. Okay, म्हणजे काय? जर तुम्ही कार्टेशियन कोऑर्डिनेट पाहिले तर आपण ते एका ब्रॅकेट मध्ये लिहितो, पॅरेंथेसिस मध्ये लिहितो in terms of x y z. So you can have that in terms of one group. Okay, so this is a group of particles. ठीक है, so that can describe the motion of the particle. But you can just say for your generalized coordinate you cannot divide it into a group of three, and so that it cannot be associated together to form a vector. इथं हे x y z एकत्र आले की आपण काय लिहितो? जसे r is nothing but xi plus yj plus zk. हे आपले वेक्टर्स इथे तयार होत आहेत. ओके, एखादा पोझिशन वेक्टर्स आपण त्याच्यावर लिहू शकतो, परंतु याच्यामध्ये हे जे काही जनरलाइज्ड कोऑर्डिनेट्स आहेत, we cannot have that in terms of a group of three, and so that we cannot be associated with a cannot be associated together to form a vector. So आपण यांची ग्रुप करू शकत नाही तीन चे, जेणेकरून हा वेक्टर फॉर्म करेल. So just remember these points. हे महत्त्वाचं आहे, कशा पद्धतीने एक्सप्रेस करता येईल ही महत्त्वाचं आहे. So you can express your position in terms of generalized coordinates, or you can say we can express your generalized coordinates in terms of position. So we'll have this 2 to 3 important points. The first one, Qj, that may not necessarily have a dimensions of length. Okay, it may be an angle theta or phi, or you can just say it can be any physical quantity. Second important point, as it is not having the dimensions of length, it just said the velocity q dot is equal to dq by dt. That is called as generalized velocity that may not have a dimensions of velocity. याला डायमेन्शन्स लिहिलेले आहेत तर जनरलाइज वेलॉसिटीला देखील तुमच्या वेलॉसिटीचे डायमेन्शन जे आहे ते आपल्याला पाहायला मिळत नाही. थर्ड थिंग इज दॅट वी कॅन हॅव दिस कंडिशन्स दॅट इज युअर qj, okay, or generalized coordinate that cannot be divided into a group of 3 so that it can form a factor. Okay, so that is your third conditions. So you have this in terms of your generalized coordinates. So remember the 2 points: degrees of freedom. What is degrees of freedom? That is nothing but the number of ways in which a mechanical system can move without violating the constraints which may be imposed on the system. Okay, so that is nothing but the degrees of freedom. What is generalized coordinate? That is the minimum number of coordinates that required to describe the motion of the system at any time. कुठल्याही particular time मध्ये इकडेही पहा एक कोऑर्डिनेट फिक्स आहे तो चेंज होत नाहीये. इथं पाहिलं तरी तो इथं पाहिलं तरी तो. Okay, so you can have that conditions that is at any time. So you have that in terms of a generalized coordinates. Now we have a next thing that is just we have to look at some examples on this. Have a point. So remember that this qj is nothing but qj of r1, r2, r3 up to rn of t. These are nothing but all vectors. So you have generalized coordinates as well as generalized velocities. Now let us say, if you can have an example of that, the previous thing, that is our simple pendulum. So for that simple pendulum, just look at this point. So this is theta. This is the simple pendulum, which is having some length L. Okay, and so let us say it is moving in that xy plane. So we'll have seen, just say this, the first constraint is that it cannot move along z axis. So the simple pendulum can move only along x and y axis, or in between that, in that plane, it cannot move in all 3 dimensional space. So first thing is z is equal to 0. What is the second thing? The second thing is that its length is fixed. Okay, as your pendulum is moving, its length is not changing. So you can just say you can have that x square plus y square is equal to x square. So that is your second thing. So these are the 2 equations of constraints. ये दोन इक्वेशन ऑफ कंस्ट्रेंट्स है. Now what we will look at? We will have to look at the generalized coordinate. What should be your generalized coordinate? So I just said I have 2 sides. Let us say this is nothing but x and this is nothing but your y. So we'll have to calculate these values. So we'll just say cos of theta that is nothing but x upon l. I'll just write it here. So you can have that cos theta is x upon l, and your sin of theta is considered to be y upon l. So what is x? X is nothing but l cos of theta, okay, and y is nothing but l sin of theta. So you can have like 2 sides. So now the condition is that how will you decide the generalized coordinate? कुठली क्वांटिटी याच्यामध्ये अशी आहे की जी व्हेरी होत आहे. So there is a quantity which is going to vary, and that is nothing but theta. सगळ्यांच्या लक्षामध्ये येतात. हे XY प्लेन मध्ये मूव्ह होतात. पहिली कंडिशन. दुसरी कंडिशन हे Z ऍक्सिस ला मूव्ह होत नाही. तिसरी कंडिशन याची लेंथ फिक्स आहे, म्हणजे लेंथ चेंज होत नाही, लेंथ व्हॅरी होत नाही. याच्यामध्ये ज्यावेळेस पेंडुलम मूव्ह होतं म्हणजे या पोझिशन पासून निघून हा इकडे कुठेतरी गेला, so just that what is changing? Angle theta is changing. So I'll have a first point. मगाशी जे काही सांगितलं ना की Q चे may not necessarily have a dimensions of length. It may be an angle. Now, what is the variable here? The variable here is theta. So I just said for the simple pendulum, the generalized coordinate, okay, that can be written as Q, and that is nothing but theta. सगळ्यांनी लक्षात येते का बाहेर लक्षात घ्या महत्त्वाचा. What is the generalized coordinate? The coordinate which is changing. कुठला coordinate change होतोय तर याच्यामध्ये coordinate change होतोय theta आणि तो जो काही coordinate change होतो याला म्हणतो आपण generalized coordinate. So what is the value of theta then? The value of theta is either cos inverse x upon L, or that is sin inverse y upon L. सगळ्यांनी लक्षात येत आहे Q ची व्हॅल्यू आहे. This is nothing but generalized coordinate, and that generalized coordinate for the simple pendulum is theta, which is varying, and its value is either cos inverse x upon L or sin inverse y upon L. So you can have a first example. I'll have a second one. दूसरे example आपल्याकडे. The example is like this. Let us say the motion of the particle constrained to move on the surface of the sphere. I'll just draw a sphere here. We'll have a consideration. So just say this is a point. Let us say this is A. You can have different conditions. Let us say you have that point here, okay, which is having some coordinate. Let us say x, y, z, or we can just have theta, phi, and let us have that point. So this is theta and this is phi. So we have that points along this x, along this y, and along this z axis. Consider a particle which is constrained to move on the surface of the sphere. एक particle आपण consider करतोय आणि तो कुठं move होतोय? That moves on the surface of the sphere. जर हा surface वरती move होत असेल तर त्यासाठी असलेलं इक्वेशन ऑफ कन्स्ट्रेंट जे आहे ते अशा पद्धतीने येईल x² plus y² plus z² is equal to a². सगळ्यांनी लक्षात येते का पहा. कन्स्ट्रेंट इक्वेशन आपल्याला अगोदर लिहायचे जसे इथे लिहिले होते तसे. सगळ्यांनी लक्षात येते कशावरून लिहितोय. आता असं आहे की हा जो एक पार्टिकल आहे इथं तो आतमध्ये येऊ शकत नाही. ठीक आहे, म्हणजे त्याची जी काही रेडियसची व्हॅल्यू a आहे ती कमी होऊ शकत नाही. दुसरा महत्त्वाचा पॉइंट हा फक्त सरफेस वरतीच फिरू शकतो, हा बाहेर जाऊ शकत नाही. ठीक आहे, सो इट इज मूव्हिंग ओनली ऑन दॅट सर्कल. ठीक आहे, जे काही सर्कल आहे ज्याची रेडियस a आहे तेवढ्या सर्कल वरती म्हणजे काय एवढ्याच भागावरती ते फक्त फिरत राहणार आहे. ओके, एवढंच फक्त ते कंटिन्युअसली फिरणार आहे, त्याची रेडियस चेंज होत नाही. ओके, सो काय चेंज होत आहे तर ज्यावेळेस हा जो काही पार्टिकल मूव्ह होतो बा त्यावेळेस फक्त दोन गोष्टी चेंज होत आहेत. सो आय जस्ट से I'll have this is in terms of a spherical polar coordinate system that is nothing but r theta phi. मग आता तुम्ही म्हणा की जनरलाइज कोऑर्डिनेट कसे चूज करायचे. Just look at here. We'll have a point that is value of r is equal to a, and that value of a is not changing, which is constant. जर r ची व्हॅल्यू किंवा तुमचं जे काही रेडियस आहे याची व्हॅल्यू जर कंटिन्युअसली चेंज होत असली तर हा देखील व्हेरिएबल झाला असता, हा देखील जनरलाइज कोऑर्डिनेट झाला असता. परंतु ही जी काही r ची व्हॅल्यू आहे ती चेंज होत नाही. r that is equal to nothing but a, and that is nothing but constant. So we'll have only two conditions that are varying. हा पार्टिकल इथल्या पोझिशन्स पासून इथं आला तर जस्ट चेक इट आउट, your theta is changing and your phi is also changing. सगळ्यांनी लक्षामध्ये येत आहे. म्हणजे आता मी पोझिशन इथनं काढून इथं घेतोय बा Okay, so I'll have different theta and different phi. माझी a ची व्हॅल्यू आहे तशीच राहिली, r ची व्हॅल्यू रेडियस, परंतु माझा थीटा चेंज झाला, माझा फाय चेंज झाला. सो व्हॉट आर द व्हेरिएबल्स? इथे काय केलं, इथे देखील तेच केले की व्हेरिएबल कुठला. सो व्हेरिएबल इन दिस केस इज नथिंग बट थीटा and phi. So how many generalized coordinates? There are two generalized coordinates. I'll just say the first is q1 is equal to theta and the second one, that is nothing but q2 is equal to phi. So you have that point, q1 is equal to theta, q2 is equal to phi. इथे आपल्याला angle check करायचे. Let us say this is equal to z. So I'll just say I will find out the value of z, and ही जी काही z ची value है, that is nothing but cos of theta is nothing but z upon a, and so this is z is equal to a cos of theta. So I have that point, and so I'll just write it here, just clear it from this point. So I'll have this is the point, and then you can have that angles. So this is theta, this is phi. Just check it out. This is the value. This is called as z. Then we have to calculate the value of phi also. So this is y, this is x. So we can just find it out. So what is z? Cos of theta for this is z upon a. So this is z is equal to a cos of theta. This is first thing. Okay. Now we'll have to find out the second thing. That is the value of phi. Okay. And that phi that can be given in terms of the conditions. So I'll just say for the first case, q1 is equal to theta is equal to cos inverse z upon a. That is the first thing. And for the second one, q2 is equal to phi, and that we can have an angle that is called as tan inverse. Okay, so tan inverse that is given as y upon x. Just check it out. Okay, angles pha with the angles for the तुमच्या लक्षामध्ये what should be the value of tan, and that tan is nothing but x y values, and so we'll have that points. We'll get the value of that angle, that is phi is equal to tan inverse y upon x. So this is x, this is y, so we'll have that point that is given in terms of that conditions. I just said that is phi is equal to tan inverse phi by x. So degrees of freedom degrees of freedom, that is nothing but 3n minus k. K is nothing but the equation of constants. So depending upon that, we have defined this generalized coordinates. Okay, so you can just express that in both the ways. Either you can express old coordinates in terms of new coordinates, that is x, y, z, that can be expressed in terms of q1, q2 up to qn. Okay, qn, where this small n is nothing but 3n minus k. What is this? Capital N. This capital N is nothing but the number of particles. This small n, that is nothing but the number of generalized coordinates. What about k? K is nothing but the equation of constants. So you can have that, can express in terms of these conditions. You can have two examples in terms of simple pendulum and in terms of your spherical polar coordinate system, or you can just say motion of a particle on the sphere. The next thing is the configuration space. Configuration space. Now remember this. We'll have the n number of particles, and so you can just say we'll have with a k equation of constants. You can write the equations or the degrees of freedom as 3n minus k. So you'll have that in terms of your n number of particles. So याच्यामध्ये लक्षात घ्या, it is very difficult to visualize this system in a three-dimensional space. Three-dimensional space मध्ये हे सगळं visualize करणं थोडंसं अवघड जातं. So we'll have to just configure it. Okay, so we'll have to look at the configuration of that system that can describe this n general generalized coordinates. आपल्याला फक्त आता 3 डायमेन्शनल स्पेस नकोय. आपल्याला आता अशी स्पेस पाहिजे की ज्याच्यामध्ये हे सगळे जे कोऑर्डिनेट्स आपण डिफाइन करतो हे सगळे आपल्याला एक्सप्रेस करता आले पाहिजे. सो वी हॅव दॅट n generalized coordinates, okay, that can be described in a configuration space, okay. So that you can just say this, you can just say have n generalized coordinates that can be defined. What are n generalized coordinates? That is nothing but q1, q2 up to qn. So this q1, q2 up to qn n generalized coordinate that can be defined in a space or in terms of n generalized coordinates, and this space, remember that the space in which these n generalized coordinates are defined, that is called as the configuration space. So guys, लक्षात येते का पहा, we have n number of particles, capital N, and then we can have k equation of constraints, so we can have n generalized coordinates. तर हे 3 dimensional space मध्ये आपल्याला चांगल्या पद्धतीने दिसत नाही. It is very difficult to visualize this condition in a 3 dimensional space. So we'll have to define a space, okay, we'll have to define a conditions in such a way that we'll just define these all the coordinates. हे जे काही n generalized coordinates आहेत हे आपल्याला डिफाइन करायचे अशा ठिकाणी, अशा स्पेस मध्ये की सगळे आपल्याला हे दिसतील, चांगल्या पद्धतीने दिसतील, किंवा we can just visualize it. So we can have to define or we have to just view this n generalized coordinates in different ways or in a space, and that space is known as a configuration space. So we'll have this point in terms of your third thing, configuration space. Now we'll have one more important point, and that is nothing but the principle of virtual work, or that is also called as a D-Lambert principle. आपला खरा चॅप्टर आता इथून पुढे सुरू होतोय. बेसिक कंडिशन्स लक्षात ठेवा. we'll have a constraint. First, constraints मध्ये त्याचे टाइप्स holonomic असतील, okay, then you can have non holonomic असतील, then त्याचं क्लासिफिकेशन duonomous असेल किंवा scleronomous असेल, then we have degrees of freedom, then we have generalized coordinates, then we have configuration space, and now we have a D-Lambert's principle of virtual work. This is D-Lambert's principle of virtual work. Now, just have a look. We'll have to consider a system with a n generalized coordinates. And here you get n generalized coordinates. So आपण लिहितोय q1, q2 up to qn, where the small n is nothing but this 3n minus p. So we'll have that in terms of a common point. We'll have that, or we can describe it in terms of a quantity that is nothing but qj. So what is j? The value of j is nothing but 1, 2, 3 up to this capital, not capital N, and up to small n. Okay. Again, that small n is nothing but 3n minus k. Now let us say a system that can undergo a small change. How much change? I'll just say this. It will undergo a change of delta r. तुमची जी काही सिस्टम आहे, okay, it can undergo a small change delta r, okay, in such a way that it does not take, this is important, this does not take any time, a system undergoes a small change delta Ri, okay, such a way that it does not take any time. Now, we'll have a displacement, and that displacement is always associated with time. ठीक है, म्हणजे एखादा पार्टिकल डिस्प्लेस होतोय, सो दॅट डिस्प्लेसमेंट इज ऑलवेज असोसिएटेड विथ टाइम. टाइम त्या ठिकाणी येतोच, टाइम नसेल तर काहीच नाही. नाउ व्हाट वी आर कन्सिडरिंग, a system undergoes a change of delta Ri, and that delta Ri that takes place, okay, does not take any time. So this change, okay, which does not involve any time, which is known as a displacement. What is R? R is nothing but displacement. Delta R is nothing but the small change in displacement, as it does not involve any time. This is called as a virtual displacement. लक्षात घ्या, the real displacement is always associated with time. जर त्या ठिकाणी टाइम नसेल तर ती रियल डिस्प्लेसमेंट होऊ शकत नाही. आपण या ठिकाणी कन्सिडर करतोय की या ठिकाणी टाइम इन्व्हॉल्व होत नाही, आणि जर टाइम इन्व्हॉल्व होत नाही तर अशा क्वांटिटीला आपण काय म्हणतोय, व्हर्च्युअल डिस्प्लेसमेंट असं म्हणतो. So this virtual displacement is just occur, or can just say that can be possible while your time is constant. So you can have that point in your mind, what should be the real displacement and what should be the virtual displacement. Now, आता या ठिकाणी टॉपिक आपला असा आहे की व्हर्च्युअल वर्क आपल्याला पाहिजे. So what is work? The work is nothing but the force into displacement. Okay, that is in terms of your real work you have just said. Now we have to look at this virtual work. Now remember this point that the virtual work is resulting from, I'll just write it here. So this virtual work that is resulting from the two things. The first thing is nothing but the real forces, and the second thing is nothing but the virtual displacements. लक्षात घ्या, आपल्याला पाहायचं आहे व्हर्च्युअल वर्क. त्या व्हर्च्युअल वर्क साठी पाहिजे आपल्याला रियल फोर्सेस, and what is the second thing? We require virtual displacement. So this virtual displacement that does not involve any time. So you can have that points. Now let us consider the I particle. Just let's consider this I particle in a static equilibrium. Okay, एका static equilibrium ला आपण सगळं consider करतोय, and it just said for that I particle the total force acting, and that is comes out to this one. So Fi t, okay, Fi t, that is equal to 0. That is your condition. Then what about your virtual work? The virtual work that is given as Fi t, that is the total force multiplied by, so this is nothing but the real force. Okay, real force multiplied by the virtual displacement delta Ri, and that must be equal to 0. So what is that point? Your point is that the virtual work, that is nothing but dW, is nothing but Fi of t dot delta Ri, and that is equal to 0. So this is nothing but the virtual work. The virtual work that involves real forces and the virtual displacement Fi t dot delta Ri, and that must be equal to 0. So you can have that conditions in terms of virtual work, but we know that the total force, okay, so that real force or that total force and is acting on that I particle, that can be a combination of the actual forces and the constant forces. Now we are talking about the forces. आपण पहिल्या चॅप्टर मध्येच पाहिलं की the total force that is involved, that get involved the internal forces as well as external forces. Now we'll have to consider in terms of Lagrangian and Hamiltonian. This Fi of t, okay, that is the combination of the actual forces, okay, plus the constraint forces. त्याच्यावरती काहीतरी constraint act होत राहतात. So this forces, that is nothing but capital Fi. These are nothing but the actual forces, and this is nothing but the constraint forces. So the total work done, that is given as in terms of this dw. आता हे फक्त I particle वरती झालं. Total system वरती झालं की summation over I. This is Fit, okay, dot delta I, and that must be equal to 0. Or I can write that this dw is equal to this summation over I. This I can just put the value of this Fi. This is nothing but Fi of t is equal to Fi actual force plus constraint force dot delta I, and that is equal to 0. So what you can write? We'll have a point, and I can write it like this. That is dw is equal to this summation over I, this capital Fi dot delta I, that is first thing, okay, plus the summation over I, this Fi, small Fi dot delta I, and that is equal to 0. Now look at this pointer. So we can have a condition that if we assume that these constraint forces these constraint forces which are assumed to be in a direction that is perpendicular to the constraint forces, this virtual displacement, if they are assumed to be perpendicular, these virtual displacements, if they are assumed, virtual displacement are assumed to be perpendicular to these constraint forces, and you can have a condition for a perpendicular vectors. दोन vectors जे एकमेकाला perpendicular आहे, okay, तर त्यासाठी आपण condition पाहिलेली आहे. Let us say like this: we can have a vectors A and vector B, okay, and if these vectors are perpendicular to each other, what about their dot product? The value of their dot product is equal to 0. Simple आहे. हा जर I असेल, हा जर J असेल, तर आपण पाहिलं I dot J याची व्हॅल्यू किती येते? 0 येते. जर डॉट प्रॉडक्ट असेल तर क्रॉस प्रॉडक्ट असेल तर I dot J is equal to K. ठीक आहे. तर हा जो डॉट प्रॉडक्ट आहे, हा I dot J is equal to 0 किंवा दोन वेक्टर जर एकमेकाला परपेंडिक्युलर असेल तर त्यांचा डॉट प्रॉडक्ट 0. इथं काय होतंय? तर ही जी काही तुमची व्हर्च्युअल डिस्प्लेसमेंट आहे, that virtual displacement is perpendicular to your constraint force, and because of this point is equal to 0. So what is remained? The remaining condition is this dw is nothing but summation over I. This is nothing but capital Fi, that is nothing but the actual force multiplied by this delta Ri, and that is equal to 0. So you can have that point, and this is known as the principle of virtual work. सगळ्यांनी लक्षात येतं what on which factor this virtual work depends? It depends upon the two things. It depends upon the real forces and the virtual displacement. Now, if you consider the ith particle, we can have that in terms of the static equilibrium, which forces is given as Fi of t is equal to 0. So, for a virtual work, we can have that Fi t dot delta I is equal to 0. But what is Fi? Fi of t is nothing but the forces, that the total forces acting on your ith particle, and that is given in terms of actual forces plus constraint forces. दोन forces act होतात, एक तर actual असेल, दुसरा constraint असेल, and so you can have a point that is this dw is equal to summation over I Fi t dot delta I is equal to 0. Or you can write that in terms of capital Fi plus small Fi dot delta I is equal to 0. But this virtual displacement is just said, we assume to be it is perpendicular to this Fi, that is constraint force, then you can just say the dot product is 0, and so only the term left is nothing but dw is equal to summation over I Fi dot delta R. This is called as a principle of a virtual work. So it involves a real forces, okay, or actual forces and the virtual displacement. So this virtual work that results from these two conditions, real forces and virtual displacement. This is given by a scientist that is known as a Bernoulli's theorem वगैरे तुम्ही ऐकलं असेल. सो ह्या बर्नौलीने हे प्रिन्सिपल ऑफ व्हर्च्युअल वर्क सांगितलं आणि मग आता याच्यावरून आपल्याला पाहायचं आहे की डी एलेम्बर्ट्स प्रिन्सिपल जे आहे किंवा त्याची जी काही ऍक्च्युअली कंडिशन्स आहेत त्याच्यावरून आपल्याला लॅग्रॅन्जियनचे इक्वेशन डिराइव्ह करायचे ते कशा पद्धतीने येतात. So just remember that this is the most important point that D-Alembert principle किंवा हे काय प्रिन्सिपल ऑफ व्हर्च्युअल वर्क आहे. त्या व्हर्च्युअल वर्क पासून आपल्याला आता काय करायचं आहे पुढचा पॉइंट पाहायचा that is called as the principle of D-Alembert principle. And so you can have that points that just remember this, there are two forces, actual as well as the constraint forces.